Hi folks, today I bring you another car radio panel to add to our collection. This one is a SONY panel, model CDXS2250S. The service manual for this unit is available online, which is always very helpful when working with these panels. This panel uses an LCD driver with the reference LC75826. Unfortunately, it was not possible to find the datasheet for this driver. Because of that, the code we created may contain some inconsistencies, especially in the way data blocks are sent to the display. Even so, by using a trial and error approach, we can build a working solution. To help with this process, we can create an analogy with another driver, the PT6526, and use it as a reference to develop a simple code structure that allows us to display information on the LCD. However, there is an important detail to keep in mind. There are differences in the position of the COM pins, the COM-X lines. Since we do not have the original datasheet, we cannot directly compare the schematic with the real pin configuration. And this configuration is different from the PT6526 pinout, so some adjustments are necessary. When it comes to wiring the panel, there are not many special precautions required. The main point to consider is the voltage applied to the pin labeled plus B. In this case, the schematic indicates a value of 9.2 volts. However, in practice, we can use any voltage above 5 volts, up to a maximum of 9.2 volts. There is also an interesting detail related to the LCD backlight system. The backlight is controlled through a transistor, which is driven by pin number 1 of the driver. This pin is configured as a GPIO, and in this panel there are 3 available GPIO pins. One important observation is that there is no external base resistor connected to this transistor. This is because the transistor already includes an internal base resistor. The function of this transistor is to short-circuit resistor R967, which has a value of 330 ohms. By doing this, the current in that branch increases, which results in stronger backlight illumination. For communication with the driver, we use the following pins: data, clock, chip enable, and /INH. The /INH pin is held in a high state through resistor R987, which has a value of 1 megaohm. It is also very important to remember to connect the ground of the panel and the microcontroller together, creating a common ground reference. The example text shown on the LCD is created by setting the bits corresponding to each segment to the value 1. In this approach, we are not building a character library. This is because the segment order can vary from panel to panel, which would make such a library unreliable. Additionally, we must deal with differences in the number of segments between digits. In this specific panel, the number of segments is not consistent and can vary between 16, 20, and 24 segments depending on the digit. With this method, we can directly control the segments without relying on predefined character mappings. By applying these techniques, it becomes relatively straightforward to bring this type of panel back to life. And the same approach can be used with similar panels that use the same LCD driver.